Welcome back. So let's move on to our fourth part of our chapter, operations on sets. So if you have seen my first video, you would have seen this as a last slide in that presentation, showing the different symbols that we'll be using in this chapter and elsewhere also. So few of these symbols already we have already seen them. That is subset symbol, we have already seen them. The element symbol, we have already seen them. The phi symbol, we have already seen. What is phi? Empty set. And these are easy because you just cross the subset symbol, you get not a subset symbol. You cross the element symbol, you get not an element symbol. Now there are two other symbols which I have not taught you yet, so we'll go to that today: union and intersection. So when, as I used to say before, whenever you see new terms, try to understand its meaning from the name itself. Union, what image does it bring to you? Does it bring to your mind? Intersection, when you hear that or see that word, what does it bring into your mind? Keep thinking. And so in the last video, I have shown you this example of people who play cricket and people who are girls. Now this is the collection of people who play cricket. Why did I use the word collection instead of set? Because both are same. Set is what? A collection of things. Okay. In being technical, a well-defined collection of things. Now so my set is more of a mathematical word. I can use the word collection also if I really want. So this is a collection of people who play cricket, and this is a collection of people or students who are girls. And we saw that this is the area where both the circles interact, or this is the space where both the circles overlap, right? That region is called intersection. Intersection is a place where both the circles interact. Okay, then we saw that this rectangle, this whole rectangle, not the white space, just the rectangle, whole rectangle outside, this rectangle is the universal set. This rectangle, whole rectangle outside, is the universal set. Why do we call it universal? Because this is my universe. In this question, everything that I want to know is given in this rectangle. Okay. In this rectangle, I have people who play cricket. In this rectangle, I have people who are girls. In this rectangle, I have people who are boys. In this rectangle, I have people who are girls but play cricket. In this rectangle, I have people who are boys but do not play cricket. I have everything that I need in that rectangle, in this rectangle, right? So this rectangle is called universal set, not the white space. Only the rectangle is called the universal set. What does the white space show? White space shows boys who do not like to play cricket. Okay, now this is the symbol that we use for intersection. This symbol. So very easy to understand. When I am interacting this set with this set, this region comes. So this is the symbol. Okay, the same symbol. So let's move on. I am bringing in front of you another example. So in a class of which school, of what section and all, you can decide. Use your imagination. Fill it in. Okay, so in a class blah 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 consisting of 40 students, that I will tell you. There are 20 people who play cricket. Okay, there are 10 people who play tennis. These are the data I have. Remember, 20 people cricket, 10 people tennis. Total 40 students. Okay. This is my Venn diagram. 17 plus 3, 20 people who play cricket. 7 plus 3, 10 people who play tennis. So these 3 people is the interactive area. These three people play both cricket and tennis. Now, and total we have 40 students. For 40 students is our universal set, right? These 40 students is our universe. These 40 students represent the whole rectangle. They are our universe. Everything that we are going to do, all operations, everything is within this 40 students. So these 40 students is our rectangle. So that is why I have not put them inside. I have written it outside here, because if I write them inside, that will be the white space. It's not the white space, it is a rectangle. 40 students, the rectangle. People who play cricket, I have pushed them into the red circle. People who play tennis, I have pushed them to the other circle. Now let's move on. I want to ask you a few questions on this. So let me bring my question back. First question: how many students do not play any sport? Now, only sports that we are considering here are cricket and tennis. Okay, so how many students do not play any sport? Everyone who plays cricket, I have put them in a red circle. Everyone who plays tennis, I have put them in the grey or blue. Which circle is this? Grey or blue? Let us be a bit diplomatic. This is the greyish blue circle. Okay, so everyone who plays cricket, I have put them in a red circle. Everyone who plays tennis, I have put them in the greyish blue circle. Right. So all those who play, I have put them in circles. So all those who do not play are where? Outside the circle. That is here, in this white space. This white space shows people who do not play cricket or tennis. That means they do not play any sport with respect to our class or our universe. Okay, now let's move on to the next question. How many students only play cricket? Nice question. Yeah, how many students only play cricket? So how do we find that? Everyone who plays cricket, I have pushed them into the red circle. So everyone outside the red circle are people who do not play cricket. So everyone who plays cricket are where? In the red circle. So these students are people in the red circle. Okay, forgive my drawing, but these people in the red circle are people who play only cricket. Is it? No, because the question says, no, the question doesn't ask how many students play cricket. The question asks how many students only play cricket. These 3 people play tennis also. So I have to subtract these people out. So let me make it more clear. So the only people who play the people who play only cricket are this red circle, true, but it doesn't consist of this overlapping place. This overlapping place doesn't come. Only this part. This part. Right. So let's move on. How many students only play tennis? The same logic. Everyone who plays tennis, I have pushed them into this grayish blue circle. So these are the people who play tennis. Now these people play cricket also. So people who play tennis are outside this place, and these are the people who play only tennis. Right. Let's move on to the next question. How many students play both the games? So as I said, everyone who plays cricket is here, everyone who plays tennis is here, right? So where are the people who play both the games? Here in this colorful regions, right? Except in the white space shows people who do not play any sport is in the white space. So people who play the games are here. Now, how many students play both the games? That means what? It is an intersection, right? It is an interactive area. So that will be this area. This interactive area is the area where the students play both the games. Okay, now moving on to the next one. How many students do not play cricket? Okay, how many students do not play cricket? Everyone who plays cricket, as I told you three or four times now, every student who play cricket, I have put them in the red circle, right? All those who do not play cricket are outside the red circle. Very easy. So everything outside the red circle. These people, everything. Tennis people do not play cricket. Only these people play. So these people are inside. Everything outside the red circle are people who do not play cricket. All the space. Right. So this has a name. How many students? I told you this is intersection, right? This is intersection. And this what we did here. How many students do not play cricket? This what we did here is called complement. It's called complement. We'll come to that soon. So union. I told you about union. Union. Look at the term. Union means uniting two sets or uniting different sets. Union, when you see the word union, you should understand that it is about uniting. It's about uniting different sets. Okay. For example, cricket, union, tennis. This is a symbol. Cricket, union, tennis. People who play cricket and people who play tennis. Not people who play both cricket and it includes people who play cricket, only cricket and only tennis also. Everyone, either he should play cricket or either he should play tennis or both. Everyone who plays basically. For in this example, it will be this union will be I'm uniting this set and I'm uniting this set. That means everyone here will be part of the union. This is the union of people who play games. So everyone in this area, everyone in the full area, everyone is part of the union. That is called union, uniting different sets. Okay, so next one is intersection. That means interaction between sets, represented by the symbol intersection. Cricket, intersection, tennis. Complement. Things needed to complete a set into universal set. Complement comes from the word complete. Now, this is the symbol. I told you we'll represent it by a complement symbol. See, this is a complement symbol. Complement means people who do not play cricket. For example, if I say cricket complement, that means people who do not play cricket. Everything that is not there in that set is called complement of that set. Let me make it more clear. I have a playground, my rectangle. I have a circle, one of my set. I have a set A. Now if I say complement of set A, that means what all I need to make this set a universal set. What is a universal set? The rectangle. What all I need to put in this set to make this universal set? The whole thing, right? Everything should be there to make this a universal set. So this is the region. Let me bring my pointer. This is the region. Everything outside A. Everything outside A is my A complement. When I say A complement, it means everything outside A. Everything that A should take in to make it a universal set. Everything outside A. So this part is called a complement. Remember that this is a symbol, a complement. Okay, let's move on. So in our example, this example, we, if you look in the last video, we saw this example of people who play, people who study, of people whose favorite subjects are physics, whose favorite subjects are chemistry, and whose favorite subjects are math. So we saw this example in the last class. This looked like a difficult example, but if you have understood till now whatever I have taught, you should be able to understand with the help of this example also. So if you look at this, if which is the set of people who study only physics? People who study physics, these people study chemistry also, so I cannot include them. Let me put them out. These people study everything, I can't put them in. These people study math also, I cannot put them in. I'll put them like this. These people study physics, so these people doesn't study anything else. I mean, they do not have anything else as a favorite. So these people are the people whose favorite subject is physics and only physics. Maths is not their favorite, chemistry is not their favorite. So this is the set of people whose favorite subject is only physics. What about people whose favorite subject is only chemistry? Same thing. I will go like this, and I can't take this part. This is considered math. So when I want the people whose favorite subject is only chemistry, then I'll go like this, and I'll take everything else out and complete the, so this part is where people whose favorite subject is only chemistry. Same thing for math. So from these Venn diagram, that is the use of this Venn diagram. The use of these Venn diagrams are, by just making diagrams of such things, making diagrams of sets, we can understand many things by looking at these diagrams. Now, it might not seem much useful to you when you're only dealing with two sets or something, but when you have something like this, 3 sets, or when you have 4, 5, 6 many sets together, it is very hard to manually calculate and write down, add, subtract and all. So by making them look like circles and putting them in your playground like this, you'll be able to understand and find many information which is not. Now in this example, I have given you only the information about how many students are there in total, and about how many students voted for their favorite subjects, and how many students said they have no favorite subjects. I didn't tell you how many people are the ones who I didn't tell you how many people are the ones who only took physics. It is shown here, but in the question I never told you that. How many people only took chemistry? It is shown here because I wrote it down but in the question it was never given to you. So all these things I can easily find with the help of Venn diagram. Now looking at this example, can you tell me how many people said they like all the subjects? Which is the interacting area of all 3 circles? This circle interacts with these 2 circles here, this circle interacts here, this circle interacts here. If you look, this part is a part where all 3 circles interact. It's part of chemistry, it is part of physics, it is part of math. So this is the region where we can find the number of students who said that they like all physics, chemistry and math. How many students are there? In this question, only 1 student. In this example, 1 student. But if the numbers were different, we will get another number. But what matters here is not the number. Number can vary. But what matters here is whether you have understood how you can find this. So I'm hope you're understanding these things. So let me move on to another a small information regarding these things. Now I want to bring in front of you one more example. That is, there are 22 teachers in a school. Okay, there are 150 students in that school. 22 teachers in a school, 150 students in the school. Now let me draw a Venn diagram. Wow. If you look carefully, there is no interaction between these two sets. Is there? No. You see a wide space. There is no interaction between these two sets. Why? Because no teachers can become students, and no teachers are students, and no students are teachers at the same time, right? So we can never find a teacher who is a student and a student who is a teacher. So there is no overlap. Even if there overlap, the overlap is, or intersection is equal to 0. There is no overlap here. There is no intersection here. These type of sets where there is no interactive area, where there is no overlap, where there is no intersection, is called disjoint sets. Okay, so I think it might be all this might be a bit too much for you to grasp in just at one time itself. But if you find a difficulty, go through the subjects, go through this video again, and if you still find a difficulty, ask me directly. Anyways, in the next video I'll be continuing on this topic itself. So try to understand, try to listen. So if you don't understand, try to look back and see, try to look again at this video and see if you can understand. This is not much difficult. The only thing that you need to take care is, you need to understand what is shown in each circle. When a circle is represented, when a circle is shown in this playground or in this rectangle, you should be able to understand what is there in that circle, whatever is not there in that circle, and whether the circles overlap, and all such things like that. So that's all for today. I think that's enough for today. So okay then, bye, God bless you all.